Hi, this is Algebra 1, Module 7, Lesson 7, and we are just going to solidify some of those things we've been learning with our quadratic equations. So now that Optima's quilts are accepting orders of rectangular blocks, their business is growing by leaps and bounds. The more options you give, the better it does. Many customers want regular blocks that are bigger than the standard square block on one side. Sometimes they want one side of the block to be standard length and the other side to be 2 inches bigger. Draw and label this block. Write two different expressions for the area of the block. All right, so we've got one side is standard length, the other side is 2 inches bigger. So that would be one side is standard times one side that's 2 bigger. So let's look at our picture of that. We've got x on one side, and then we've got 2 blocks on the other side, x and 2. So that one seems somewhat familiar. To do this, I'm going to distribute to get x squared plus 2x. So there's two different ways of writing the one side x, the other side 2 inches bigger than x. So sometimes they want blocks with one side that is standard length and one side that is 2 inches less than the standard size. Okay, so let's draw and label this block. So this one would be x, and this side would be x, and we are going to actually take away 2. That's how we're going to show a minus 2 on there. We're taking them away. You know what? I'm going to take away that part because that looks like 11. That's not helpful. Okay, so let's write what that looks like. So a of x would be one side is x, the other side is 2 less than x. So that's one way of writing it. When I distribute, then I end up with x squared minus 2x. So that's how that area looks. Okay, let's look at the third one. There are many other blocks requested, with side lengths all based on the standard length, x. Draw and label each of the following blocks. Use your diagrams to write two equivalent expressions for this area. Verify algebraically that they are equal. Okay, so for 3, one side is an inch less than the standard. The other side is 2 more. Okay, so we have to draw our picture first. So here's our standard. One side is 1 less. The other side is 2 more. Okay, so I need to take away the one side here, and I'm adding the other ones. So what I get is, where's the color I need? Let's look at our equation here. So one side is an inch less, one side is 2 bigger. I guess I didn't label. This is my x and my extra, and I'm getting rid of the 1. So when I solve this out, we are going to do our distributive on this one. So I'm going to do x squared, 2x, minus x, minus x, minus 2. So it's going to look like x squared plus 2x minus x minus 2, which equals x squared, combine these guys, 2x minus x is a positive x, minus 2. So I end up with this as 1, and then I kind of messed up my other, didn't I? That's how those look like. And I have an x squared, and yeah, added 2, took away 1. So this one cancels out that one, so I'm left with 1 extra, and I have 2 on there. Then well, if I take away that whole length, I'm taking away these guys as well. All right. Yeah. All right. So let's go to the next one. One side length is 2 inches less than the standard. The other is 3 more. So here's my original square. I'm going to add 3 on this side, and I'm going to take 2 less. Okay, so I'm taking out 2 of these. My paperwork with me. All right. So, taking out all those guys. Okay, so when we do this, a of x equals, I've got an x minus 2 and an x plus 3. So when I go to figure this one out, I'm going to do my not simplified one in green here so we can tell the difference. So I have x squared, that's these guys. Now I'm going to do plus 3x minus 2x, and then I'm going to combine those guys to be a negative 2 times 3 is a negative 6. So when I put this all together, I end up with x squared. 3x's minus 2x's is 1x minus 6. There's that one's equation on there. So I got rid of all those on the others. Okay, let me erase this because I have to see my words. One side is 2 more, the other side is 3 less. Okay, so here I'm going to do my standard square. Oh, here I'm going to do 2 more. I didn't quite make him square, so that's a plus 2. And we're taking away 3. So these guys are all going to be taken away. And so a of x equals 2 more, x plus 2. The other side is 3 less, x minus 3. And so now when I put this together, it's x squared minus 3x, and then plus 2x. 2 times negative 3 is negative 6. So then when I put that together, it's x squared. Negative 3 plus 2 is a negative x minus 6. If you notice, if I take away 3 of these, I only have 2 to replace them. So I'm still short an x to make that a square. So that's how we're getting those positives and negatives in there for the visual piece. Okay, so one side is 3 more than the standard, the other is 4 less. These are going to get harder to draw. I'm going to put them over here. One more space. Okay, 3 more. 1, 2, 3. And then this is 4 less. 1, 2, 3, 4. And so I'm going to be taking out all of these guys in there. So a of x equals 3 more, x plus 3. The other side is 4 less, x minus 4. And so when I go to distribute, I have x squared, and then I have minus 4x plus 3x, and 3 times a negative 4 is a negative 12. So I'm left with x squared. Negative 4 plus 3 is negative x minus 12. And that's, you're right, if I'm taking away 4, but I'm only putting 3 more on, then I'm going to be short 1 rectangle on there. And number 7. Okay, one side is 4 more than the standard. The other side is 3 less. So I've got my standard. I'm going to do 4 more this time. And now I'm going to take away 3. 1, 2, 3. So these are my getting rid of across here. All right. A of x equals 4 more, x plus 4, 3 less, x minus 3. So notice how we're just kind of switching these around to see what happens. So I have x squared minus 3x plus 4x, and then 4 times a negative 3 is minus 12. So that gives me an x squared. Negative 3 plus 4 is a positive x minus 12. So again, if I add 4 on there, but I'm taking off 3, I still have kind of balanced it out with 1 extra and still have 1 left over. Okay, an expression has 3 terms in the form ax squared plus bx plus c is called a trinomial. Look back at the trinomials you wrote in questions 3 through 7. How can you tell if the middle term, b of x, is going to be positive or negative? Well, if we look back at least on these guys, since we can see them over here, I took away 2, I added 3, my x was positive. Took away 2, added 2, took away 3, it was negative. Added 3, took away 4, negative. Added 4, took away 3, positive. So what I'm seeing there is when if I'm adding more than I'm taking away, I end up with a positive. If I'm taking away more than I'm adding, I end up with a negative. So let's write that here. B will be negative if you're subtracting from one side. So if you're subtracting more from one side than you are adding to the other side, and vice versa. In other words, B's negative if I'm subtracting more from one side than I'm adding. It'll be positive if I'm adding more than I'm taking away. All right, one customer says, had an unusual request. She wanted a block that is extended 2 inches on one side and decreased by 2 on the other. One of the employees thinks that this rectangle will have the same area as the original square since one side was decreased by the same amount as the other side was increased. So, what do you think? Let's use this diagram to figure it out. So, let's make so I have this one. I'm going to increase it by 2, but then I'm going to decrease the other side by 2. And so let's see what happens. A of x equals x plus 2, x minus 2. Okay, well, x squared, these guys, and then I'm going to take away 2x. I'm going to add 2x. 2 times a negative 2 is a negative 4. So what I end up doing is doing x squared. These two cancel each other out, minus 4. So I've got these two squares back down here, but I'm missing my little guys in here. Even though these come around and fill in that gap, I'm still missing those 4 squares in the corner. So they're not quite the same, but they have the right idea in that these rectangles will replace this one. Let's look at the next one here. The result of the unusual request made the employees curious. Is there a pattern to predict the two expressions for areas when one side is increased, the other side is decreased by the same number? So let's try modeling it one more time and see if we can find a pattern. So for this one, it's an x plus 1, and then an x minus 1. So let's take out this guy. And so if we write this out, we end up with x squared minus x plus x. 1 times negative 1 is negative 1. So that equals x squared, these two cancel, minus 1. Okay, let's check the next one out. Plus 3 minus 3. So this side we're going to extend by 3. And this side, oh, we're going to decrease 1, 2, 3 by 3. Oh, by the way, so again, we had this one be able to replace this, but we're still missing our one box that would be in the corner. All right, let's work this one out. So x squared, x times negative 3 is negative 3x. 3 times x is 3x. 3 times negative 3 is negative 9. So when I go to solve this, I end up with x squared, negative 3 plus 3, those cancel, minus 9. So again, these 3 come around, replace this, but I'm still missing my 9 in the corner. So what pattern are we noticing with this result? Well, what I see is it was, oh, I don't need parentheses. I have my x squared, and then the 3 squared is 9, 1 squared is 1, and before it was a 2, 2 squared was 4. So I take away my a squared. It's a bad a. There we go. So it's x squared minus a squared is what we end up with on here. All right, looking for more patterns. Some customers want both sides of the blocks reduced. Draw a diagram for the following blocks and find the trinomial expression for the area of the block. Use algebra to verify the expressions you found in the diagram. So we're going to have x minus 2, x minus 3. So here's my box. I'm going to take away 2, I'm going to take away 3, and I'm going to show you something a little bit different on this one. Okay, so when we do this algebraically, we've got x squared minus 3x minus 2x, and then negative 2 times negative 3 is plus 6, which equals x squared, negative 3 minus 2, negative 5x plus 6. Notice I end up with a double negative. I've taken them away, and I can't take it away twice. So it's almost like you're kind of bringing it back on. You need to have that extra material to come back to kind of make up for what you're missing on there. So that's kind of how you justify some of that on there. Okay, so the next one, x minus 1, x minus 4. Okay, so 1, 2, 3, 4, and 1. Okay, so x squared minus 4x minus 1x plus 4. So if I put this together, x squared minus 4 minus 1 minus 5x plus 4. So if we look back over all these equivalent expressions we've written so far, explain how you tell if the third term in the trinomial will be positive or negative. So here they ended up positive. Here they were all ending up negative. How do we tell the difference? Let's see, text box here. So if both sides are reduced, then what happened? We reduced both sides. C ended up being positive. Or if both sides are increased, right? Up until today, we were using plus on both sides, and it was still a positive. If one side is increased and the other is reduced, then C is negative. So if we've got one of each, kind of like our positive negative rules, we've got one of each, it's negative. If they're both the same, both reducing, both increasing, then we have positive. Next, last page. Optimus Quilt Shop has received a number of orders that are given as rectangular areas using a trinomial expression. Find the equivalent expression that shows the length of the two sides of the rectangle. All right, so on these guys, let's see how we can figure this out. So we know, let's see, all these right now have 18 on the end. So if you remember how we did last time, we looked at two numbers that added, or added to get 9 and multiplied to get 18. So I'm going to look at the factors of 18 since that seems to be what's consistent in here. So if I come over here, 18, I can do 1 and 18. I can do 2 and 9. I can do 3 and 6. 4, 5, nope, that's it. Okay, so this is positive. So I know that they're either going to be both positive or they're going to be both negative. So because this is positive, they're both positive or both negative. Well, the 9 is also positive, which means I'm going to be, when I add them, I'm going to get a positive number, and they both have to be positive to multiply to get 18. So I'm going to be adding on this one. So let's look over here. 1 plus 18, that's 19. That's not going to work. 2 plus 9, that's 11. 3 plus 6, that's 9. So I must be using 3 and 6, because 3 plus 6 is 9. 3 times 6 is 18. Let's look at this one. Here I have a negative. So I know that the signs are going to be different. One's going to be a plus, one's going to be a minus. And I know my bigger number has to be positive because I end up with a positive 3. So let's go back over here and take away these. Now I want to know, when one's negative and one's positive, what do I get? Well, the bigger number needs to be positive. So this right-hand side needs to be positive. So I'm going to have -1, -2, -3. So -1 plus 18 is 17, too big. -2 plus 9 is 7, still too big. -3 plus 6 is 3. This is the one I need because I have a 3 right here. So it's a -3 and a positive 6. 6 plus -3 is positive 3. 6 times -3 is -18. All right, next one. I'm going to use a different color so that we can kind of keep these straight here. So now I have a negative again, a negative. So I know I'm going to have an x plus and an x minus. And this time it's a -3. So I know my bigger number is going to be negative. So now if I go through here, I'm going to have 1 plus a -18 is -17. 2 plus -9 is -7. 3 plus -6 is -3. So I need my 6 negative this time and my 3 positive. Okay, next one. I don't necessarily want negatives this time. Let's see what we need. So this one, I have a plus, which means they're both the same or they're both different. Or sorry, they're both the same, both positive, both negative. That's what I meant. And let's see. Oh, I have a negative over here. That means I know they're both going to be negative. So when I add them together, it'd be a -3 and a -6, or -2 and a -9. And I know that 3 and 6 make 9. So -3 times -6 is a -9. Negative 3 times a negative 6 is a positive 18. Negative 3 plus negative 6 is a negative 9. Whew. Okay, now let's try the ones with 4. So we've got 2 over here with 4. So the factors of 4 are 1 and 4, 2 and 2. So let's look at this. It's a positive. Okay, so I know they're both going to be the same. And it's a negative over here, so they're both supposed to be subtracting. So which of these two, when I add them, add up to 5? Well, 1 plus 4 does. So one of them is a 1 minus 4, one is a 1 minus, or x minus 1. So negative 1 plus negative 4 is negative 5. Negative 1 times negative 4 is a positive 4. Let's try this one. This one is a positive. It's also a negative here. So double negative, and they need to equal a negative 3. Oh, you know what? I think this one's a typo. I think I figured out this was a typo last year. So this should actually be a minus, because otherwise it doesn't make sense. There we go. So that's a minus. Okay. So negative. So I'm going to have one of each. And my over here, it's a negative 3, so I know my bigger number is going to be negative. So I'm going to go over here and go negative 4. Well, those two are the same, right? So negative 1 minus 4 is a negative 3. 2 minus 2 is 0. Oh, can't use that one. So I know it's negative 4 plus 1. Minus 4 plus 1. Okay. Next. Last one on this page. 15. So 15's got a few options. I have 1, 15, 2, 3, and 5, 4. Oh, nope, just the 2. Okay. So it's a negative. This is negative, so I know it's going to be a 1's positive, 1's negative, one of each. And I need it to equal a positive 2, which means my smaller number will be my negative. So negative 1 plus 15 is 14. Negative 3 plus 5 is 2. So I'm going to do a minus 3 plus 5 and get my factors there. All right. So let's write an explanation as to how we're getting this. So what did we do to be able to do all that? Let's see if we can break it down. Okay, so one, write out x. Okay, so first we put our x's in our parentheses, right? So decide on signs. What are we doing? Adding or subtracting? So, for example, if B and, where's my and, C are positive, then it's an x plus and an x plus. Okay. But if C is positive, but B is negative, then we have an x minus, typing this right? C is positive. Back here is positive. Let's see this one. Back here is positive, but B is negative. We know we've got both negative. And if B is negative, then you know it's one of each. All right. 3. I have room to type all this in here. I think I should. So 3. We want to find the factors of C. Pick two factors that multiply to make C, which is what factors are. Add or subtract them to make D, whatever the signs say. If they're the same, we want to add. If they're different, we want to subtract. Give the larger number the same sign as B. So when they were different like this, we want to subtract. And when we subtracted them, we got a 2. And I know that I needed to have the bigger number be positive because my answer was positive, the same sign as B. So there's kind of the word written out of what we did up here on this top part. Thanks for joining us, and we'll see you next time.